So today we are doing a hard problem 980 unique path 3. You are given a grid. So grid ij is a starting square, ending square, empty squares, and obstacles. Return the number of 4 directions from the starting square that walk over every non-obstacle square exactly once. Okay, first question of course is okay, well, here it comes. So this is, wait, m times n is, so there is at most 20 pieces. So this seems like you wanna do like so it's 20 times 2 to 20. Oh, okay, well, this is a giveaway that we want 2 to 20. So what I'm thinking is that we have a mask of positions, and then we visit it, we like convert position to integer, and from 0 to 20, and then what we try to do is we try to visit okay, so first question, can starting cell be ending cell? They don't say. Can it be on an obstacle position? They don't say, but I guess whatever. Okay, so my DP, so let's start with some backtracking, because that's how we roll. So let's say mn is len grid, and then len grid 0, and then so let's see, we can map def encode, let's do it like this. So def encode ij, number of columns, I times n plus j, okay, and then def Leetcode x n return xn, and then x percentage n. I think that should work. And then finally, okay, we need to, so that's n obstacles is sum of 1 if grid ij is, what is obstacle, -1 for j in range and for I in range m. That could work. Else 0. Okay, that's fair. So there's number of obstacles, and then we need starting row, starting column is while current row, current column equals decode I if grid ij is 1, ending row, ending call is this. So then starting row 0 call if grid ij is 2, then ending row, ending call, current row, current call. Okay, and then that's fair. 0 call let's call start is I and is I, start and this. Okay, that's great. And then okay, so let's start with DFS, and now let's say so that's so we have, what have we chosen? So the last position was start, and then our mask is this, and that's actually what we return. So let's define DFS, and this is the, let's say, last pos and mask, last bit, let's call it last bit. And now what we want to do? Well, if I should probably use self here and self here and then self here, and then what we want to do. So if good question. So if one, 2, m times n minus 1 and mask is equal to mask, let's see, maybe this will work. So if all non oh, that's weird, wait a minute. Okay, so done mask is 1 to the m times n minus 1. Okay, and now if grid 0 call is minus 1, then done mask we XOR it with 1 to I, maybe should work. So if mask done mask non-local done mask. Okay, so then we are done, right? So we return this, right? And otherwise we can make LRA cache here, and then what we try to do. So ans is this, we return ans, and then what? For I in range m times n, right? And now if done mask shifted by I and 1, right? so it's not blocked, right? And another thing is that mask shifted by I and 1 is equal to 0. That's great. Okay, so it's not set, right? Then ans plus equals dfs I mask or 1 to I, maybe. If the mask and last bit is equal to end, I mean, I guess this is it. Okay. Okay, that's rough. Okay, so what's up with this? So last bit was 0, 1, 2, 0, 1, 2. Oh, I'm not checking neighbors, that's why. Okay. And neighbors, last bit I mn. Okay, let's see. Def neighbors self, and then that's bit 1, bit 2, mn, right? And then do you really need that? So that's like row 1, column 1, decode bit 1, n, row 2, column 2, decode bits 2, n, and then good question. So I got this, and now for dx dy in and now if r1 plus d rows delta row delta col and column 1 plus delta column is equal to row 2 column 2, okay, this works. Now let's see if it's fast. Okay, that's kind of slow, but I mean the time complexity is number of states, which is m times n times 2 to m times n times m times n. So m times n squared times 2 to m times n. I mean, that's not best, but backtracking. What? Path controls plus markers. Okay. So non-obstacles. Okay, backtrack start row, and that's number of non-obstacles. So when we are doing backtracking, okay, that's interesting. What? -4? Explore potential offsets if it's inside and not visited, then we backtrack, and this, and now there is no way this works. What? In Java and Python? What? Okay. Okay, but 3 to n with n equals to 20 should not work. That should not work. That's that's not great. This is not optimal. I mean, because that's not optimal. Who cares? Okay. Bitmask GP. So I mean, depends, because I have m times n squared times 2 to m times n, and they have 3 to n times m. So I mean, mine is eventually better. Asymptotically, I think I'm better than exponential, but only slightly, I think. But whatever. So try to visit all paths with BFS. We need to know in each position is what we need to know. So our state is the position we are currently in, and the already visited cells. At each such step, in each such state, we can move to any neighboring cells. So then I guess technically I can lower the time complexity to just neighbors, but okay, that's fair. Okay, so let's say current row, current column, self, decode. phew. So we decode last bit, right? And then we go 0 decall in 0 minus 1, and then new row, a new call is equal to 0 plus dr, and then c call plus dc if 0 n row, so new row is less than number of rows, and new column is less than number of less than number of columns, not less than. And whew, okay, so that's next bit is self encode n row and call a number of columns, and whew, mask mask shifted by next bit and 1 is equal to 0 maybe. So we have not visited it yet, and not sure if including this will make it slow, but and done mask shifted by next bit and 1 is equal to 1. I guess I can just exclude this and then put like not here maybe. Okay, and then ans plus equals dfs next bit mask or 1 to next bit maybe. I'm not sure, this might even be slower. Okay, that's way faster, so we got to 35 milliseconds, but we are still way too slow. So I mean, whatever, I guess. Okay, so I'm not sure, I just copy this or what, but why is this here? What is that? Oh, okay, well, anyways, to any unvisited, unblocked, unvisited neighboring cell with out an obstacle slap memorization on our states, we get a time comp. We visit om c dot n c dot 2 to power of m c dot n. Okay, maybe I can skip this because skip this. Okay, everyone probably just turned off the video, the one person who is still watching, but whatever. So we visit mn states since there is mn possible current positions and 2 to mn possible visited sales, in reality visited paths, in reality it's way less. It's not probably way less, maybe. And for each such state we do when checking, by checking neighbors, the Leetcode for neighbors, okay, giving us the time complexity of O of m and c dot c dot 2 mn. Okay, and I can delete all this because who cares? Yeah, that's quite fresh, but my code is a little disgusting, but who cares? Okay, goodbye.